Hello everyone, welcome in the module Isometric Projections. In this module we are going to see the basics of isometric projections. So basically isometric projection means converting the 2D drawing into 3-dimensional drawings. So the isometric drawings is the type of pictorial projection in which all 3 dimensions of an object are shown in one view, and if required, their actual sizes can be measured directly from it. In these 3D drawings of an object, all 3-dimensional axes are maintained at equal inclination with each other, that is 120 degree. 3D drawings can be drawn in different ways as shown below. All these drawings are called as 3-dimensional drawings or photographic or pictorial drawings. Here there is no any specific relation among the axes. So if you observe the drawing, in this drawing there is no any relation among the axes T, L and H. So for every drawing they are making different angle with each other. So these types of drawings are called as 3-dimensional drawings or photographic or pictorial drawings. Now if you observe the isometric drawings, the axes used in the isometric drawings are making 120 degree angle with each other. Here the word iso means same, similar or equal. So that's why these drawings are called as isometric drawings. The purpose of isometric drawing is to understand overall shape, size and appearance of an object prior to its production. Now some important terms: isometric axis, lines and planes. Now if you observe the isometric drawings, here O is the origin point and through that origin point 3 different axes are drawn. So that 3 different axes are OL axis, OD axis and OH axis. These 3 axes are making same angle with each other, that is 120 degree. Here these axes are called as isometric axis. The lines parallel to these axes are called as isometric lines. If the planes representing the faces of cube as well as the other planes parallel to these planes are called as isometric planes. So if you observe this cube, so in this cube these faces are called as isometric planes, or if there are other faces which are parallel to these faces, they are also called as isometric planes. Now next term is isometric scale. When one holds the object in such a way that all 3 dimensions are visible, then in the process all dimensions become proportionally inclined to the observer's eyesight and hence appear apparent in the length. This reduction is 0.815 or 9 divided by 11 approximately. It forms a reducing scale which is used to draw the isometric drawings and is called as an isometric scale. So for isometric drawings, if a particular reduction scale is used, then that particular drawings are called as isometric projections. And the scale used to reduce the dimension of the object is called as isometric scale, which is approximately 0.815. Now there are types of isometric drawings: isometric view and isometric projection. In the isometric view, it is drawn by using true scale, or you can say the true dimensions. So the true dimensions of the object are used to draw the isometric view. In the isometric projection, the isometric scale or reduction factor is used. Reduction factor is 0.815. So if the drawing is drawn by using isometric scale, then it is called as an isometric projection. Now we will see isometric of plane figures. So how to transfer the 2D figures on the isometric planes. So we will see different shapes of the 2D plane. First shape is a rectangle. Now this rectangle you have to transfer on the isometric plane. Now for this, first you have to create an isometric plane. So there is a particular procedure for creating the isometric plane. First you have to draw the reference axis. Now on the reference axis you have to mark point O, that is a reference point. Through that point you have to draw a line at an angle 30 degree on either side, and you have to draw the vertical line. So these two lines are the isometric axis, and with this isometric axis you have to create an isometric plane, and on that plane you have to draw the given shape. Now for transferring this rectangle on the isometric plane, you have to consider a reference point from this rectangle A, B, C, D. Now suppose there is a B point which is reference point, and by considering B as a reference point, we will try to transfer this rectangle on the isometric plane, which is made because of HL axis. This L axis is making 30 degree angle with the reference axis, and H axis is a vertical axis. Now for transferring this rectangle on the isometric plane, first you have to mark point B at the reference point O. So considering this B point and O point at the same location, then you have to measure the distance BC and mark that BC distance on 30 degree inclined axis L. Then measure distance AB and mark that AB distance on the vertical axis H. Then through A point draw a line parallel to the 30 degree inclined axis L, and through C point you have to draw a line parallel to the vertical axis H. The intersection of both lines will give you the D point. And like this you can transfer the rectangle on the isometric plane. This rectangle is transferred on the vertical isometric plane. Now if you observe, it's easy to transfer the rectangle or square shape on the isometric plane, and that's why shapes containing inclined line we prefer to enclose in the rectangle or square, and then first we prefer to draw the isometric of the rectangle or the square, and then the inscribed shape which is inside the rectangle or square. So suppose we have to transfer the triangle. So we have a triangle with nomenclature 1, 2, 3. Now this triangle is having inclined line, that's why we prefer to enclose this triangle into the rectangle. Now this triangle is enclosed in the rectangle 1, 2, AB. Now to transfer this rectangle, first we will draw the reference line, and then we will create a vertical isometric plane by drawing the axis L and H. Here axis L is making 30 degree angle with the reference axis, and H is the vertical axis, and both axes meet at a reference point O. Now first we will transfer the rectangle on the isometric plane, and for transferring the rectangle we will consider 2 number as a reference point which lies at the intersection of the both axes. And with the above procedure, first we will transfer the rectangle on isometric plane. Now after drawing this rectangle on the isometric plane, this 1, 2 edge of the triangle is already transferred on the isometric plane. So 1 number point and 2 number point are already marked on the isometric plane. Now for marking third number point, we will measure the distance A point to third number point, then we will mark same distance as it is on the AB line from A point. So this third number point lies on the AB line. So by just measuring the distance, we will mark the third number point on the AB line. After getting third point, just we have to join this 1 number point to third number point and second number point to third number point to complete the isometric shape of the triangle. So this triangle we have transferred on the vertical isometric plane. The same procedure can be used to transfer the triangle on the top plane. Now next shape is pentagon. Now again the pentagon is having inclined lines, so we'll first enclose this pentagon into rectangle 1, 2, 3, 4. Then for transferring the pentagon on the isometric vertical plane, first we will draw the reference axis, then we will draw the axis L and H, which are making 30 degree and 90 degree angle with the reference axis. They are meeting at a one point, that is a reference point O. By considering 2 number point as a reference point, first we will transfer this rectangle or square onto isometric plane. So like this we can transfer the rectangle or square onto the isometric plane by using same procedure as we used to transfer the rectangle. Then we'll mark the different points of the pentagon. This A point lies on the 1, 2 edge of the square or rectangle. So by just measuring the distance of A point from second number point or first number point, we can easily mark this A point on the 1, 2 edge. Similar way, we can mark the E point on 1, 4 edge, D point on 4, 3 edge, and B and C points on 2, 3 edge. After getting all points, we have to join all points so that we will get the shape of the pentagon on isometric plane. With the same procedure, we can transfer this pentagon on top plane. Now next shape is circle. We are going to enclose this circle into a square. Then first we will transfer this square on the isometric plane, and by using 4 center method we can easily draw the circle on the isometric plane. Now first we will see what is 4 center method. So for drawing a circle onto the isometric plane, 4 center method is used. So the isometric planes are the inclined planes. So when we incline the circle with a specific angle, it looks like an ellipse. 4 different centers are used to draw the shape of the ellipse. Now first we will transfer the circle onto top plane. Now for transferring the circle onto the top plane, first we require reference axis. Now for transferring the square onto the top plane, through reference point O, we have to draw the 30 degree inclined line on the both sides. And then by marking the dimensions of the square on that inclined line, we can easily transfer the square onto the top plane. It looks like an rhombus. Then you have to find out the midpoint of the edges of that square and give nomenclature as A, B, C and D. Then you have to identify the shortest diagonal from this rhombus. Then you have to join the shortest diagonal points on the opposite edge centers. So it means bottom point of the shortest diagonal you have to join with A and B point, and other point of the shortest diagonal you have to join with D and C point, which are the midpoint of the opposite edges. Now because of this particular procedure, you will get 4 different points named as 1, 2, 3 and 4. Now by using these 4 points as a center, we can easily draw an ellipse. Now by using 1 as a center and 1A as a radius, we can draw an arc from point A to point B. Then by using 2 as a center and 2C as a radius, we can draw an arc from point C to D. Then by using 4 as a center and 4B as a radius, we can draw an arc from B to C. And finally, by using 3 as a center and 3A or 3D as a radius, we can easily draw the arc from A to D. This completes your ellipse. This is the 4 center method, which is used to transfer the circle onto any isometric plane. So same procedure can be used to transfer the circle onto the vertical plane. For that, you have to draw the reference axis. Then you have to draw two axes. One is making 30-degree angle with the reference line, and second one is a vertical axis. By considering that two axes, we can easily transfer the square onto the vertical plane. Then you have to follow the procedure for drawing an ellipse. First you have to find out the midpoint of the edges of that rhombus. Then you have to identify the shortest diagonal. Then you have to join the shortest diagonal point on to the centers of opposite edges. Because of this procedure, you will get 4 centers, that is 1, 2, 3, 4, and then by using these 4 centers you have to draw an ellipse. So by using 1 center and 1 to A as a radius, we will complete AB arc. Then by using 2 as a center and 2C as a radius, we will complete arc from D to C. Then 3 as a center and 3A as a radius will complete arc AD, and finally 4 as a center and 4B as a radius will complete arc B to C. So like this you can transfer the circle onto the vertical isometric plane. So hexagon, you have to fit that hexagon into the rectangle or square, and then you have to transfer that hexagon on the isometric plane. Same procedure you can use as we used in the pentagon. So same pentagon procedure you can use for transferring hexagon itself. So this is transferring of hexagon on the vertical plane, and this is transferring of hexagon on the top plane. The circle procedure we have already seen. So rhombus method or 4 center method we can use. The same way you can use to transfer the semicircle. So while drawing the semicircle on the isometric planes, instead of using 4 centers, you have to use any 2 centers depend on the semicircle given. So depend on the straight edge of the semicircle, you have to choose a particular centers for drawing an ellipse. So in this given figure, the straight edge of the semicircle is horizontal, and the semicircle lies above that horizontal edge. So you have to choose appropriate centers for drawing an semi-ellipse. So if the semicircle is given below that straight edge, then different 2 centers you have to use to transfer that semicircle on ellipse. So it depends on the semicircle drawing that which centers you have to choose for drawing an semi-ellipse on the isometric plane. Now this completes the basics of isometric projection. Now in the next video you will see how to draw the isometric object from given 2-dimensional views.